All right, welcome to this briefing. If you are a senior portfolio manager trying to figure out exactly where to deploy capital across infrastructure and software right now, you are in the right place. Because today, we're unpacking a massive, fundamental shift in how we actually need to look at the artificial intelligence cycle. We have to stop, completely stop, treating AI like a pure software play. It's not. What we are actually looking at is a macro-industrial infrastructure build-out. And the current valuation models dominating the equity markets, well, they are on a direct collision course with the rising costs of long-duration capital. So let's break down exactly why that's happening. I want to anchor our entire discussion around one specific reality. In software cycles, the limit was belief. In the AI era, the limit is physical. That really hits the nail on the head, doesn't it? The ultimate limitation of this current tech expansion has absolutely nothing to do with algorithmic capability. It's not about lines of code. It is entirely rooted in atomic reality. We're talking power, land, raw materials, and time. So, here is our roadmap for today. We'll start by debunking the dot-com illusion. Then we'll compare software versus physical scaling before hitting what we call the physical constraint wall. After that, we'll examine the infrastructure financing loop, look back at historical capital destruction cycles, and finally wrap up with the migration of economic value. Okay, part one, the dot-com illusion, and why comparing today to 1999 is totally missing the mark. You hear it all the time, right? The market loves to compare this AI cycle to the late 90s internet bubble. But structurally, that comparison is completely flawed. Think about it. The dot-com era was wildly speculative. The infrastructure was immature, and let's be honest, half those companies lacked any viable business model. The internet boom temporarily busted because the monetization infrastructure lagged way behind the software demand. But the AI era? It is the exact opposite. We are seeing highly measurable, massive enterprise demand, and it's being driven by the most profitable hyperscalers in economic history. These guys aren't wandering around searching for a business model. They are actively deploying industrial-scale capital. We're talking capital expenditures on track to exceed $700 billion by 2026. Make no mistake, this is not pets.com. Moving to part two, software versus physical scaling. This is where the timeline mismatch really rears its head. We are currently experiencing a massive, massive divergence in scaling velocities. The demand for AI, that scales exactly like software. It's fast, it's exponential, it's just code improving by orders of magnitude in a matter of months. But the deployment of AI, that scales like heavy infrastructure. It is slow, it is stepwise, and it is stubbornly physical. And when you smash exponential software demand into the slow, grinding reality of building physical infrastructure, well, a massive timeline mismatch opens up. To break it down simply, the software world relies on cheap copying, instant global distribution, and rapid iteration. You can push an update worldwide in literally seconds. But physical infrastructure? That means slow builds, incredibly lengthy permitting processes, and total constraint by physical reality. You can't just hit a button and instantly spawn a massive data center campus or a nuclear power plant. Those take years, and sometimes decades, to get permitted and built. Which brings us to part three. The physical constraint wall, the actual on-the-ground reality of deployment. We are hitting highly inelastic industrial bottlenecks right now. Consider this number, 160 weeks. That is the current lead time just to get your hands on a substation-class transformer. Think about that. That's over 3 years. You're waiting longer than a congressional term for a single piece of essential hardware. And it gets worse. Grid interconnection queues across the U.S. are currently averaging 5 to 8 years. We literally have 2,300 gigawatts of generation and storage projects just sitting in these queues. To put that into perspective, that waiting list is actually larger than the entire currently installed generating capacity of the country. This completely reimagines the traditional Gartner hype cycle. Now, normally, the hype cycle is basically a psychological phenomenon, right? People just get overly excited and then lose interest. But in the AI era, it's a physical cycle. The peak of inflated expectations assumes scaling is frictionless and infinite, but we are actively slamming into a physical constraint wall. Power capacity, grid interconnection, semiconductor supply, water access, these are real limits. The inevitable trough of disillusionment isn't going to happen because the AI technology itself fails. It's going to happen because our physical infrastructure literally cannot be built fast enough to keep up with these exponential expectations. All right, part four, the infrastructure financing loop and how this all collides with macro financials. These immense physical capital requirements are slamming headfirst into our current macro financial environment, and it's creating a massive contradiction. We're essentially looking at two markets telling two completely different stories. The equity market narrative is pricing in infinite scaling, explosive growth, and those beautiful, high, asset-light software margins. But then you look at the bond market. The bond market is signaling capital scarcity, rising duration costs, sovereign borrowing stress, and deep industrial bottlenecks. It's a fundamental contradiction. Both of these markets cannot be right. And that is perfectly illustrated by the AI infrastructure financing loop. This shows how AI behaves like a heavy industrial capital cycle, not some low capex software loop. Because the hyperscalers' aggregate capex budgets are now exceeding their projected free cash flow, both they and the utility companies are forced into a structural reliance on debt markets. They have to borrow heavily. This entire AI build-out relies fundamentally on cheap, abundant, long-duration capital. So the moment the cost or the availability of that capital shifts, the entire loop starts to grind. Let's actually trace this loop step by step. It's basically a domino effect. Step 1, you have insatiable hyperscaler compute demand. Step 2, that triggers a tsunami of semiconductor and data center orders. Step 3, running all that requires huge, massive power infrastructure expansion. Step 4, to pay for all that concrete and copper, companies have to turn to debt and private credit financing. And finally, step 5, because global savings are finite, drawing down all this capital creates massive sovereign borrowing pressure. And that, of course, leads to inflation pressure and rising refinancing risks across the board. So let's quantify this macro reality for a second. 5.046%. That was the clearing rate for a recent $25 billion 30-year U.S. Treasury auction, an auction that, by the way, saw pretty subdued demand. Remember, infrastructure operators raise their debt across multi-decade horizons. The cost of that long-duration capital is heavily, deeply embedded in their core unit economics. To give you a sense of the scale of this shift, just look at the 30-year government bonds yield. Since hitting lows near 1% back in 2020, yields have risen roughly 4 to 5-fold. That is a massive structural repricing of duration-sensitive capital. And remember, AI isn't borrowing in a vacuum. It is competing for the exact same stressed pool of capital that governments are using to finance the energy transition, domestic reindustrialization, and defense spending. That repricing heavily impacts the utility-style unit economics required to actually make AI deployment profitable. Let's move to Part 5, Historical Capital Destruction Cycles, because we have actually seen this movie before. When we look back at historical precedents to see how civilization-scale infrastructure deployments usually play out, a very distinct, very sobering pattern emerges. Every single infrastructure revolution, whether it's the railroads, electrification, telecom fiber, or the early internet, follows the exact same arc. A new technology scales rapidly, that triggers massive euphoric investment, that investment inevitably leads to overbuilding, and that overbuild results in a brutal capital destruction cycle before the enduring societal value is finally established. Basically, technological success is not the same thing as investment success. The historical overbuild impact is painfully clear. During the railroad era, roughly 25% of all tracks went bankrupt, and 50% of the bonds defaulted. In telecom fiber, we were left with a $1 trillion debt overhang and widespread dark capacity just sitting in the ground. In memory semiconductors, we saw severe margin compression. The pattern is undeniable, folks. Exponential adoption drives massive investment, and that inevitably leads to capital destruction. Right now, AI infrastructure is very early in this cycle. The big investment phase is just beginning. But as portfolio managers, you absolutely have to prepare for the eventual overbuild impact. Finally, Part 6, the migration of economic value. Where is the pricing power actually going to live? If you want actionable strategic intelligence, you need to know where economic gravity will ultimately settle in your portfolio. Consider the capex to revenue ratio. Currently, for the hyperscalers, this ratio sits between 45 and 57%. Just 5 years ago, it was in the mid-teens. A 50% ratio is historically associated with regulated utilities, telecom operators, and heavy industrials. It is absolutely not associated with software platforms. As capital intensity reaches these utility-like levels, the unit economics fundamentally diverge from the high-margin, asset-light software models that the equity markets are so happily pricing in right now. And that brings us to the machine economy stack. Right now, almost all the market's attention and valuation is hyper-focused on layer 4, logic and orchestration. The software, the models, the apps. But the structural economic gravity is actually pulling downwards. The real binding constraints sit lower down the stack, specifically at layer 2, energy and compute. Let me be clear, if the AI boom ends, it will not be because of a lack of demand for layer 4 software. It's going to be the exact opposite. It will face a severe correction because we failed to scale layer 2, the physical, energy, and compute infrastructure, fast enough to sustain the market's expectations. Because the overarching macroeconomic rule during any constrained build-out phase is always the same. The bottlenecks capture the value. They always have and they always will. The physical scarcity in power grids, in advanced cooling systems, and in semiconductor supply chains means that these specific physical bottlenecks will command disproportionate pricing power. The value always migrates to the constraint.
So I'm going to leave you with this final thought. Intelligence clearly scales exponentially, but can your capital sustain the slow, grinding speed of infrastructure? As portfolio managers, you have to reconcile your software-era valuation frameworks with the undeniable realities of physical limits, decade-long deployment timelines, and rising sovereign yields. The limits of AI are no longer just in the code. They are in the concrete, the copper, and the cost of capital.